Welcome back. I'm Dr. Angela Siegel, and today we're going to take our first look at arrays. This is an incredibly useful data structure that I'm sure you will be thankful to add to your tool belt. Sometimes we want to store a set of related information. For instance, we might wish to store a set of strings that represent the names of students in a class. In these situations, we want to make use of something called an array. Arrays are used to store collections of values of the same type. Each element of the array has a unique location. Just like strings, the index of these elements starts at 0. This means that the last element of an array of length n can be found at position n-1. You can think of arrays as parking lots and its elements as parking spaces. Imagine a car park with spaces numbered from 0 upward. The elements of the array, the parking spaces, are all separate, but they are each ready to hold similar items. In this case, all are cars, but each car is unique. Together, they make up one whole, the parking lot. Arrays, like strings, are of reference type. Array variables only store the location of the array elements, rather than the array itself. Continuing onward with our parking lot theme, when we refer to a parking lot, what we give is its location. At that location, you will find all of the cars in the parking lot. However, in order to access them, you only need to know the location of where to find them. In order to declare an array variable, you first give its type, followed by square braces, and then give the desired array name and a semicolon to end the statement. In our example, we are declaring an array of type double and calling it array name. What that statement does, double square bracket array name, it creates a new array named array name, and the elements inside of it are of type double, so it's ready to go. You have not yet declared how many elements are inside this array. We'll see that on the next slide. A reminder that arrays can be declared anywhere that you could declare any other variable. However, just like other variable types, do not use reserved words or already used names. Now that we have declared an array variable, it exists, it has the name nums, and it's ready to hold something, an integer array. In this example, an integer array named nums, we are ready to instantiate the array. An array may be instantiated using the new operator. In order to do this, we use the new operator, followed by the type of array needed, and then we give the size of the array. When this happens, appropriate space is allocated to hold the specific array. In this case, we're given enough space for 12 integers, and that array, in creating it in this form, is initialized to zeros. After that has been created, this is assigned to the variable nums, and so that reference that we spoke about is now pointing to this location, which has space to hold 12 integers. So if we take a close look at what is happening behind the scenes, this is what is going on. Let's look at this example where we have an integer array named r, which is instantiated as a new integer array that can hold 5 integers. Note that we did all of this in one line, declaring and instantiating the array variable all at once. Just as we did with other variable types, we are able to do the same with arrays. So as we instantiate the new variable, we are reserving space in memory to hold 5 integer elements. The size of the array cannot be changed once after you instantiate it. As we instantiate the new variable, we are reserving space in memory to hold 5 integer elements. Note that the size of the array cannot be changed after you instantiate it. You're setting up an array variable The compiler now knows how many elements there are in the array, and after that point, you cannot change the size without asking for a new array. So let's look at some examples. Here's an example of declaring and instantiating an integer array, as we've seen before. In this case, we're creating an integer array named array name, which can hold 8 integers. Note that when the integer array is instantiated using the new operator, each element in the integer array holds zeros. Here is an example of declaring and instantiating a double array. This array is instantiated to hold 16 elements. Note that because the indices of these array elements start at 0, this means that the last element in the array can be found at index 15, even though there are 16 elements in the array. Also note that because these elements are of type double, instead of being initialized to 0, these elements are all initialized to hold 0.0. Finally, here is an example of the declaration and instantiation of a string array that will hold 5 string elements. We see that although the length of the string array is 5, the positions of each string element will be from index 0 to index 4, totaling 5 elements. When the string array is instantiated, the initial string elements are set to null. This means that the item in array name 0, while ready to be accessed, does not yet hold anything except for this null value as a placeholder for the string to come. Another option that we have available to us with arrays is the opportunity to declare and initialize the array all in the same moment. And the way that we do that is we give the type, followed by square braces, the array name, and then we decide if we know what the content list is that we want to hold in that array, we can do that all in that same moment. And so we follow our array name with the equal sign, and then squiggly braces to hold each of the elements that we want to hold in our array, following all of this by a semicolon. So in this case, we have an integer array named factors, and we want to initialize that array to hold 3, 5, and 7. So what that blue line does, it now creates an array named factors. The elements inside of it are known to be of type int, and space is reserved for 3 integer elements. So we never told it that there would be 3, but that number was counted by the compiler. We provided 3 integers, 3, 5, and 7. The compiler realized that was 3, and so it reserved space in memory for 3 integer elements and initialized those values to 3, 5, and 7. So if we now ask for factors 0, we wanted to find what was at index 0, we would get that 3 back. We could do the same with the 5 and the 7. So here are some examples of declaring and initializing an array all in one line, and times that we might wish to do that. So the first line is a string array holding the days of the week. These never change. We don't want to write this out multiple times, and sometimes we might have calculations that require us to find which day of the week something is. The second line is an integer array, days in month, and this holds the number of days that exist in any month of the year in order. So January has 31 days, February in a non-leap year, 28, March 31, and so on. And there are times we might need to use this in calculation, and we don't want to have to look that up. So if we have a program where we need to make use of that, that's when these arrays become really powerful. The next line is a string array holding the names of students in a class. Then a double array having the average sales per department. So say there were, in this case, 4 departments in your store, you could have an array that holds those average sales, and they can be updated over time. A Boolean array holding the answers to the test, true, false, true, true, false. A character array holding letters. In this case, letters in a name. So now that we have these elements in an array, how do we access them and make use of them? Array elements can be accessed and assigned just like other variables. In this case, we need to use that index to specify which element of the array we wish to access. So in this case, this is an example of an assignment statement where we have the variable name nums, and we want to assign the value 3 to nums index 0. And so to do that, we just write nums square bracket 0 equals 3. It looks like an assignment statement that we've seen before. The only difference is that we have to specify that index. And what that does is it looks to nums. Remember, this is a reference type. It goes to find that position at index 0, and it overwrites that with a 3. We'll see later that we're going to really make use of this fact when we get to loops. So next week, we'll take a look at loops. And when we get to loops, we'll see that we can make use of the length of an array. And we can get that back by using nums.length. That returns the size of the array. And now we can loop through the elements of the array and output its contents. This becomes really powerful if we can use arrays to output information, tables of data, for instance. So let's take a look at the following code and think about what it might be doing. So the first line says int square bracket nums. So we know that this is declaring an integer array. The next line sets nums equal to 3, 1, 4, 5. And this is okay. We know what this does. This is initializing the contents of nums. And in fact, it's instantiating that to be an integer array that will hold 4 elements. All good? So we look at the next line. What does this do? Int square bracket vals, so that's declaring an integer array named vals, and we're setting it equal to nums. So you might be thinking, I know what that does. I know what's in nums. So vals is now doing the following. It's declaring and initializing an integer array vals. In fact, it is not. And this is a common trip up that people make. The reason it's not is because recall that array variables are of reference type. So what they hold is not the contents. They hold a reference to the location to where these contents are. So when we assign the value held in nums to the integer array vals, what we're assigning it is a reference. We're saying point to the same place. In fact, what we're doing is we're creating 2 variables, nums and vals, that refer to the same array. So with that gone, what it actually looks like is as follows. We have 2 variables and they're both pointing to this one location. And so if we make a change to nums, it will make a change to what's held in vals. They are pointing to the same place. And that's an important thing to keep in mind. So that's all for now. Thanks for watching.
Why do you always have to do lists?
You don't always have to do lists. You can also use tables. These are the extension of arrays. They are 2D arrays. Get ready, because we are going to see them next.
What? No. Why do you always have to-do lists?
Oh, I guess because I'm busy.
Thanks for watching.
See you next time when we explore 2-dimensional arrays. As a last note, I'd just like to thank the Creative Commons for all of the images that I use.